So far, we've worked with publishers that have their failure type set to never. That means they are guaranteed to never throw an error, and so we don't have to handle the errors. When you're using the assign subscriber, this is actually a requirement. You must handle errors before trying to assign the value to a property of an object. If you fail to do this, the code won't compile. And so if you're working with a publisher that does have an error type other than never, then you're going to have to transform or otherwise handle the error, which will eventually transform the publisher you're working with into one that has never as its failure type, and then you can use the assign subscriber. So let's look at an example of a publisher that can fail. So here I have a struct dummy error that inherits or implements the Swift error protocol, and then we have a subject that is a pass-through subject that's going to receive some int values, and then the error type is set to dummy error. So if I assign a subscriber to this, so we'll have the sync subscriber, and notice that when I have an error type other than never, the only sync subscriber, or the sync overload that I have, makes me add the receive completion event. So we'll have our completion, and then we'll have our value here. So before, we were able to use the shorthand version that skipped over completion because oftentimes you don't really care about it if the completion, or rather the failure type, is never. But if it's possible for this publisher to fail, the compiler wants you to handle that failure. So here we can print out the completion event, and we'll also print out the value. Okay, so here we have a subject with a subscriber, and now we can send some values through it. So I'll send the value 1, and then we'll send the completion event, and here we'll say that there's a failure, and we have a new dummy error that we pass through, and then we'll also send the value 2. And if I run this, notice that we see the value 1, and then we see the completion event with our actual instance of the error, and we don't see value 2. Now, why is that? And this is because, if you recall back to when we talked about the publisher lifecycle, a publisher will not emit any values after it is completed, either successfully or with an error. So let's try catching this error with the catch operator. So the catch operator expects a block with a structure that looks like this. There's some sort of error type that we're going to get into the block, and then we need to return some new publisher. So catch works maybe slightly different than you might think, in that we are expected to return a publisher, not a value. So let's create another subject. This time I'll call this one subject 2. It'll be a pass-through subject of int and dummy error. Now in subject 2, we're going to catch errors. So notice that we have a catch and a try-catch, and we'll talk about the try-catch in a minute. So catch allows us to take a handler. This handler function expects the error type that we're working with, so in this case dummy error, and we have to return a new publisher. So let's push enter to expand that block. We'll get the error in. We can print out the error if we want to, and then we need to return some kind of publisher. And here I could maybe return just -1. And I'm going to delete this for a second, and let's just see if the compiler can figure it out. And oftentimes you're going to see this. The compiler can't figure this out at all, mostly because I have 2 statements here. If I were to simplify this and have just this, now the compiler can figure out that I am returning a publisher that is a just publisher that has an int value. Sometimes it can't figure it out, and I think we should just get used to the fact that we're going to have to be decorating our types in the blocks often when working in Combine, when doing anything non-trivial. So here we're going to be taking the error in, and I need to return something, and I can pass the type that I want and to give the compiler a little bit of a hint. Okay, so now that we have that, let me copy this sync block here, and we'll attach it onto the end there. And now we can take subject 2, make sure we're using it on the right one, subject 2.send. We'll send the value 1, and then we'll subject 2.send a completion with failure dummy error. Okay, and then we will also send subject2.send the value 2. Okay, so now let's run this, and we're looking at this part right here. So we get the value 1, and then we get a error, dummy error from this block here. So it caught the error and it's returning a new publisher. And this publisher is then subscribed to by the sync subscriber. So catch is allowing us to intercept an error event and instead return a new publisher that then gets subscribed to, which emits the value 1, which we can see here, and finishes. So if you notice here, we actually get in our sync subscriber, we get a successful completion event, and this is coming from the just publisher. So in this example, we still aren't going to get any further events. We still don't get the number 2 sent down the stream because we did get a completion, but it's important to note that the completion we got came from the just publisher. Now, this is really handy because it allows you to stitch together behaviors. You could say, let me try to fetch this resource, and if that fails, let me replace that whole stream with a different entire stream. Now, in our case, we just had a value right now, so we use the just publisher. But if you had, fetching a file from a database, and if that fails, maybe we try to fetch a file from disk, then you could have 2 different streams, one that fetches from a database and one that fetches from disk. And in the catch block of the database one, you could fall back to some other asynchronous behavior. And the nice benefit of using Combine for this sort of thing is that it doesn't matter if it's asynchronous or synchronous, if it's a complicated workflow, or if it's a simple one, you sort of just catch it and return that new publisher. Okay, so in this case, we have this behavior where we're catching an error and replacing that error with some sort of known Sentinel value. There is actually a shorthand for this. So what we can do, let's create a subject 3. This time we'll use one that takes some integers, and we'll have publisher there. So this is actually not a subject, it's a publisher. We'll call this pub3. And so we'll say pub3, and this time I want to call try map. Now, you may have noticed already that there's a lot of operators that are prefixed with the word try. And all of these work just like their other counterparts, so we're going to be mapping values. But the try variants of those methods allow you to throw errors inside of these blocks. So here I'm going to try map this value, and I'm going to say if the value, let's give it a name, if the value is less than 2, then we're going to throw dummy error. Otherwise, we're going to return the value. Okay, so we're going to end up throwing an error here and here, right? So again, we're at this situation where it doesn't really like our expression here, doesn't really know what we're returning, which is a little silly because sometimes it will figure it out. For instance, if I just use $0, sometimes it figures it out this way. So again, I think we just need to get used to the fact that we probably need to tell it what we are returning. And so in this case, I'm going to be returning an int. And then this method is also a throwing method, which also can be important. So we could say throws here. Okay, so now we have a publisher. Here we had a publisher that had a failure type of never. After the try map, now we have a publisher with a failure type of this. So what we can do is print out pub3. Notice that it is a sequence array publisher. But if I say pub4, which is the next step in the chain, print pub4, you can see this is a try map sequence array, etc. So what we need to look at next is if we take the type of this, then we can get its output type, which should be integer. And we can also get its failure type, which in this case is error. So this is an important thing. Right now, there's no way for us to tell the compiler that this block throws only dummy errors. So we're saying that it throws any error, some kind of error, And there's nothing to tell the compiler that we always throw dummy errors. So the type of our downstream publisher, pub4 at this point, after the try map, it doesn't know that it's a dummy error. And so it has to roll back up to the most generic version, which is error. So that's something to keep in mind. And if you're wondering what type of your publishers are, this is kind of a neat trick to grab the type of that publisher and do .failure, and then it'll tell you what it has. Okay, so at this point, I want to take pub4, and I want to change this from a publisher that can produce an error to one that cannot produce an error. And I could do that with catch, as we saw already, but we can also just say replace error with and pass in a value. So this does the exact same thing as our catch returning just above, but it's kind of an optimized case for that. And then finally, we can say sync. And then at this point now we have a receive value only because the upstream publisher is a failure type of never. And I can just say, okay, here, give me the value. So if we run this, now we can see if I print out the actual values that we get 4, 2, 5, and -1. 4, 2, 5, and -1. So then if we go back to the one where we had a receive completion, so we can just copy this code here. Let's run this one more time. You can see that we get 4, 2, 5, -1, and then we finish. So the result is exactly the same as the catch. As soon as we get to an error condition, which is this one, it throws an error which halts this publisher, this upstream publisher. It halts it completely. And that's because replace error is internally doing a catch and returning with a just this value. And just this value is then subscribed to. It emits the value it has and then completes. And that's what we see. So the result is exactly the same. So it's important to know that we're not going to continue processing the values from the upstream publisher. At that point, it's canceled because we threw an error. So again, there are some nuance here that is important to know. So usually if you just want to replace something with a simple value, we're going to use replace error. But if we have some more interesting behavior that we want to do in the case of an error, then we're going to implement the catch and return an entirely new publisher. So if we have a publisher with an output type of int and a failure type of never, and we use the map operator, and the map operator takes a block which transforms the int value into a string value, what we've done is we've essentially created a new publisher downstream that is a publisher of strings with a failure type of never. Now, if we switch this operator to the try map operator, this allows us to throw an error from this block. And if we do that, the downstream publisher has now been turned into a publisher that has a failure type of error. And again, as I mentioned last time, the Swift compiler has no facility for automatically determining what types of errors are thrown from a block. So the error has to be the generic error protocol and not our specific dummy error. So we can use any of the try variants of the operators if we need to be able to guard against some bad input or halt execution for specific cases. And there's lots of them like try map, try filter, try scan, try max, and try min, and many others. So let's look at a quick example. Here I've got a publisher of integers, and those are going to be denominators. So I can say denominators dot try map, and here I want to take that, and we want to check to make sure, because I want to do, in the end, I want to do return 10.0 divided by that denominator. So let's bring the denominator in, and I want to be able to say, okay, let's convert that to a double and do 10 divided by whatever value is in here. But I need to guard against dividing by 0, so we're going to say guard d not equal 0, else throw divide by 0 error. Here I need to tell it that I'm going to be returning a double. And now let's add on the sync subscriber onto the end of this, and we'll do receive completion and receive value. We'll print the completion, and then in receive value, we will print the value. So here we can see that we divide by those different numbers, and then we get our divide by 0 error. So there's also try-catch. And try-catch is kind of an unfortunate collision of common terms. It is more like try-map than it is try-catch some behavior. So basically, it's just like the catch operator like we saw before, where we take in an error and we have to return a publisher. But the additional benefit we get by using try is that this block can also itself throw errors. So let's say we have a try catch which receives the error from the upstream publisher. So here we are in here if we got a divide by zero error. Now our job here now is to return something. So I could return 0 if I wanted to, and try catch is allowing us to return 0, which maintains the double output of the upstream publisher. So now sync still sees a publisher of doubles, but because we catch the error and return something, it subscribes to this, and then we get a 0 and then finishes. But let's just say that we want to either intercept and then throw errors. Like we could do this. We could say, got an error, if we just want to see it, and then we can just throw that same error, which will allow that to pass downstream. So the problem with this code right now is that downstream it doesn't know what the type of output this thing should be returning. We don't actually tell it anything. So in this case, I have to give it some sort of publisher that defines the output here. So I could say I return a just double. So even though I don't, the compiler allows me to continue because we're just throwing an error here, and it knows we don't have to return anything from this block. So in this case, this allows us to log and continue the fact that we got an error. Another reason why this might be advantageous is, let's say we have two different types of errors, and maybe one of them is kind of like a error bad input calculation or something like this, and some weird error that we get from some third-party library, or maybe we get many different types of errors, but we kind of want to roll them up into one. And so let's say this is maybe coming from a library and they give us some sort of weird error, and we want to wrap that and provide our own friendly error downstream. Maybe that has some localized descriptions or failure recovery, or maybe just aggregates a few different types of errors under one category. So here we could say if the error is the error bad input calculation, then I can throw divide by zero error. Otherwise, maybe I throw the original error because that's not the one I handle. Okay, so we can see we're still logging the original error, but allows us to throw the divide by zero error downstream. So this is a good way to kind of unify and roll up errors so that you can simplify them for whoever is subscribing to this. Sometimes we'll want to be able to change the failure type of a publisher. So given this publisher here, which has a failure type of never, I can actually set the failure type to any error protocol that I want. I could say set it to error.self, and now I have a publisher that says that it outputs an error. So why would you want to do this? Well, there are some operators in Combine that only worked when the publisher's output and failure types match up. For example, combine latest works like this. Let's say we have a subject here, which is a pass-through subject that also takes integers, but says that it produces an error. And let's say I want to take these two publishers and I want to combine latest. So I'll say publisher1.combine latest to subject, and now it's going to give me an error because the output types have to match up, and they do, and the failure types have to match up, and in this case they don't. Now, if I still want to sort of treat them all the same, I can set the failure type here to be error.self, in which case now they both have a consistent failure type, and now this works. So, of course, we know that publisher1 will never emit an error, but we're treating it in the same way to satisfy the compiler. There are some cases when you want to encapsulate and provide a friendly error like we talked about last time, and I use try-catch for that, which is technically possible, but there is actually a better way to do that sort of thing, and that is with map error. So let's take a look at an example for that. So let's say we have an enum for some friendly errors for networking reasons. And let's say we have an unable to connect type of error, and we also have other, which will wrap any kind of URL error. And let's just simulate some sort of network publisher that'll be a pass-through subject for some string response data we're getting from the network, and that happens to return to us URL errors. Okay, so now I can take this network publisher, and I can take any errors that it receives and use map error, which is going to give me the URL error that we have. Let's get the error. We'll switch on the error. And in the case of URL error dot bad URL or URL error dot cannot connect to host or URL error dot not connected to internet. There's a whole bunch of these, and they're all kind of in the similar vein. So here's network connection lost, and there's a bunch of others, but that's good enough for now. And here, let's say we just want to roll those up with friendly error dot unable to connect. And in any other case, we can return friendly errors dot other and pass in the original error. So we've essentially wrapped it and provided a nicer interface so that downstream clients can just say, oh, okay, there's this certain class of errors of unable to connect that I can handle. So in this case, again, the compiler can't figure out what we're doing here. So we're going to have to tell it that we return friendly errors. And this is important because now if we take a look at the results of this and we print out type of pub.output and then type of pub.failure, and we run it, we can see that we get a string and the failure type is friendly errors. So it has properly set the failure type of that downstream publisher. Now there are cases where you want to do the reverse. Say you have this network publisher and it produces errors, but just for running the example, or maybe it does produce errors, but you're sure that that's actually not possible at runtime, then you can use assert no failure. And if you've done that, and we look at the result of this, let's print out that type of publisher. We'll just look at this publisher's failure type. And when we look at that, we can see the failure type is never. So basically, assert no failure is saying, okay, I'm going to switch the downstream publisher's failure type to be never, but internally, I'm just going to crash if there is actually an error. So this is really good for quick examples, or if you're sure that this could never happen, but the publisher you are working with happens to have a failure type associated with it, then you can use assert no failure. And this is also really useful during debugging and initial exploration, so you can just get things working without having to worry too much about error handling. Okay, let's take what we've learned and put it into practice. So I have an application here on the right, and this is what we're going to build in this video. So it's got a dice image, and if we tap roll dice, it's going to roll the dice, and then every once in a while we're going to get an error here that is going to say that the dice rolled off the table, and it's going to present an alert, and we can re-roll it if we want to. And it's basically a 1 in 4 chance to get the dice to roll off the table. Okay, so that's what we're going to build. What I have here is a view controller and a dice view model. So in the view controller, we've got outlets for the button and this image view. Notice that the button disables while it's rolling, and there's a little animation, and then the image is set to the appropriate dice image based on the value that we rolled. Now the dice view model is what's going to contain all of the state, so whether or not we're rolling and what the current dice image is and that sort of thing. So let's go ahead and get started. What I'd like to do is have the dice image be set to whatever this value is set to and change over time. Now to do that, we're going to set the published property wrapper on that. And we're going to do the same thing for is rolling, because this will allow us to react to whether it's rolling and start our animation, and also disable this button. So with those two things, we can go into our view controller. And in the view.load, we're going to set up our subscriptions. So the first one, we're going to say viewModel.$DiceImage. So this gives a publisher for UI image. We need to map this to an optional UI image. And I'll just comment this out so you can see what happens if we don't do that. And then we're going to say assign to on. We're going to be assigning to a dice image view, and the property will be image. Now, if we run this, we can see that we get this kind of familiar error. We saw this a while back when we were looking at UI text field, and it said UI control has no member text. This is a very similar issue. I'm not sure why Xcode or the Swift compiler gives us this type of error message, because we're dealing with an image view, not a UI view. But it's saying that this property doesn't match because the types don't match, and that's because we need it to be an optional UI image. So then I map it to that, and now I get a warning saying that I need to actually save off this subscription, and we're going to store this in our cancellables set. So now when the dice image changes, no matter when it changes, it's going to automatically update our image view and keep that in sync. Next, we're going to check the isRolling publisher, and when that changes, we want to map this to the inverse of what it is right now, and that's because when it is true, I want the button to be disabled. So we flip the Boolean here, and then we assign this to our roll dice button, and the property is going to be isEnabled. And we store this in cancellables. Okay, now let's handle the animation. So we're going to say $isRolling again. So this is a second subscription on the same publisher type. This time we're going to sync to get the value, and I'm going to do unowned self. The reason is that I know, and we also need to grab the value. I know that it's safe to do this here because we're going to be hanging on to this subscription in our cancellables set. So anytime this happens, our view controller is definitely going to be in memory. So what we need to do here is take the dice image and set its alpha property. We'll check the state of isRolling. If it is rolling, we're going to be half opacity, otherwise we'll be full. And then we'll also do the same kind of similar thing for transform. Checking isRolling, and we'll use CG Affine transform with the scale of X and Y, and we'll do scale of 0.5 and 0.5. And if we are not rolling, we're going to go back to CG Affine transform.identity. Now, all of those things I want to be in an animation block, so we'll do UI view animate. And with duration, we'll do half a second animation, and we will move this stuff inside of that. Okay, so then we also need to store this in any cancellables or our cancellables set, and we'll do a build. So far we've just wired up this behavior so that any of these properties change, we know how to react in our view controller. The next thing I want to do is handle this roll dice tapped, which is going to happen when we tap on this button. And for that, we're going to go over to the dice view model. We have this roll dice method, which is not currently implemented, and we need to figure out what we want to do here. So before I write this, let's first write a method. So this will be a private func roll, and this is going to return an any publisher for some integer value, but it optionally will give us a dice error. And the dice error that we have is rolled off table. So what I'd like to be able to do here is check some sort of random condition. So if I do like 1 to 4 and check to see if that equals 1, then that is a 1 in 4 chance essentially of getting an error. And here I would want to do something like return fail and pass in dice error dot rolled off table. And if that didn't work, or if that didn't pass this random check, now we can create our random dice values, which will be in the range 1 to 6. And now I can return just and pass in the value that I got. Now we're going to get some compile errors here because we're saying that we need to return any publisher. So I could do that and say, okay, erase to any publisher. And if I do that, this branch succeeds because fail, even though I didn't tell it what kind of output type it has, it does infer the error type because I passed one in here. And I call erase to any publisher, and we're returning that, and it knows to sort of infer the fact that it's an int. Now on this side, if I try to use erase to any publisher, just has a failure type of never. And so this isn't going to work because it's giving us an any publisher of int and never, not an any publisher of int and dice error. So in order for us to get that to work, we would have to do set failure type to dice error dot self. Now there's one other sort of curveball I want to add here, and I want to add a little bit of a delay for when you roll the dice. Now we can do that with the delay operator, and so I can say delay for 1 second, dispatch queue.main, and I would have to do this in both cases, which is unfortunate. And so I don't really like this here. And so what I'd like to do is sort of wrap this up into a different structure that would allow us to have one publisher return value rather than multiple. So to do that, I'm going to use a future. Now, a future is typically used
to produce a single value and then finish or fail based on some existing behavior that you have. So if you have some code that is maybe executing some asynchronous work and then it passes a completion callback for when that data arrives, then you can wrap that up in a future and turn the completion callback code into a publisher. And that's what you would use future for. So the way you use future is by initializing it with a block, and that block takes a promise. Now, these two terms are sometimes interchangeable, but they have some nuanced differences. They're two sides of the same coin. So a future is a wrapper around a single value in the future, and a promise is essentially the same thing, but you deliver the value through the promise. So another way to look at it is this is a read-only return value, and this is the internal one that we can write to say if the promise succeeded or failed. Now, this is essentially a function that we have to call. So we would call it like promise, and then we pass in a Swift result. So it'd be a result of either failure with an error or success and the value. So what we need to do is just take this code here, and we're going to move that up into the future. And instead of returning a fail here, what we can do is say that the promise failed with that dice error. Now we can delete the other two lines here. And now I'll do the same thing here. This time I will say promise.success and pass in value. So now I have a future. And if I call erase to any publisher, I'm going to get the correct output for that because it can infer that I called it with a result of success with an integer value here and a result of failure with a dice error here. So it knows how to line up those types. And now the type of our future has an output type of int and a failure type of dice error. And so it lines up just fine. And now I have a nice place to put our delay for 1 second. Okay, so we have this roll function. Now, I want to call that from roll dice and somehow deliver the value back to that view controller. Now, the way I'm going to do this is by having a private var for a roll subject. And this is going to be a pass-through subject with the output type of void and a failure type of never. And we'll initialize it like this. So oftentimes we can use subjects to sort of trigger actions, and they're not going to take any input. It's just what we're going to end up doing here is call roll subject.send, and we're basically sending in a signal to roll subject to tell it to, perform its work. So if we have that, then we can, in our initializer, which I will add here, we can now subscribe to roll subject and do things with it. Thing that would be really nice is to be able to take when this gets a value to sort of execute this at that moment. And for that, we can use flatmap. So if you recall, flatmap will take the value from the upstream publisher, which in this case is just an empty signal. It's a void, but it is a signal. And as soon as it gets the value, it's going to call flatmap with that value. So in our case, there's nothing there. And then we just need to return a new publisher. So for this, we can return roll. Okay, so now we've turned this empty sort of signal into calling this publisher here. Okay, so let's add unowned self here so that we can avoid a retained cycle. And again, this is being retained. This whole chain is being retained by self, or will be. And so in order for us to use self inside the block, we have to use unowned self there. And so what we've done now is we've transformed this into whatever this is producing, which is an any publisher of int and dice error. Now I want to take this int and I want to assign it to a publisher. And we can even make this publisher internal. So I can make it a private published var that is called dice value. This will be an optional int because if we roll it off the table, then we can use nil there. So that is going to be our internal publisher. Published value. And so I can take this, whatever is coming out of this guy, and I'd like to assign that to this publisher, but I can't use assign. Now, if you recall back, assign requires that the publisher you're subscribing to has a failure type of never, and that's not the case. So that means we need to handle the error. So we can handle the error right here. we can say catch, and we get the error in. And now we need to take this error and we need to do something with it. For right now, I'm just going to print it out so we can see it happening. And then I need to return a publisher here. And if it rolls off the table, I think nil is a fine value for that. So I'm going to help the compiler out and say that we return an optional integer. If we try this, it doesn't work because roll is producing a value of int, and that means that whatever we catch also has to continue that same value. So it's saying that int and int question mark are not equivalent. So I can coerce this type by mapping it to, I can say $0 as integer question mark, integer optional. So now the publisher we have is producing optional integers. We catch it and return nil. And now when we subscribe to this downstream, now we can use assign to and pass in the address of the $dice value publisher. And again, we don't need to store this subscription anywhere because that's one of the features of using this publish property wrapper. So we've now handled errors and allowed the chain to continue by getting a nil value here. Okay, so what can we do with this dice value? Now, sort of separate from this whole chain, we can break apart this problem now and think about it separately. What do we do in dice value changes? Well, I want to change the image. So I can say that let's subscribe to $dice value. And I want to map that. And we're going to call this method down here dice image for value int. And let's use the value optional int there. So I can say map that value to dice image for and pass in that image or that integer. Now I'm going to get a UI image out of that. And I can assign this to our dice image publisher, which is $dice image. Okay, let's also use unowned self here. Okay, so now let's take a look and see what's happening now. Actually, I need to ask the view model to roll dice there. Now let's run it and we'll see what the behavior is that we get. I click roll dice and I get back a new value. And what we're not seeing is the animation here, but it is showing up the image, and that's fine. So what we need to do now is tell it whether or not it's rolling or not. So to do this, I'm going to go back over to this publisher here that is telling us whether we're rolling. And on this, I want to chain on a side effect. And so what we're going to use for this is the handle events operator. Now, handle events allows us to sort of place a tap on the middle of a stream and get events for what's happening on that stream, whether it was just subscribed to, whether it's receiving values, whether it was completed or canceled or received a new request from the subscriber. And all of these are optional blocks, so we only need to implement the ones that we're really interested in. So in receive subscription, we can handle that in order to set is rolling to true. And I actually don't care about the value or the subscription itself. I just want to know when it happened and set is rolling to true. Now, if we receive a completion or a cancel, then we can set, so here we'll get the completion we'll set is rolling to false here. And we'll do the same thing if we canceled, is rolling equals false. And I don't really care about receive output or receive requests, so we can just delete those because these blocks are all optional. Now, handle events doesn't change anything about the stream we're working with. It's just going to call these and allow us to either log things or set some additional state based on what's happening. So this is usually where I like to manage this sort of thing. Okay, with this in play, now when we roll the dice, it is setting the state of is rolling correctly. And it allows us to get these new values. It's also disabling the button. And you can see when we do get an error, it'll show the question mark for our dice. Okay, so what I'd like to do next is allow the view controller to display that alert. And for that, we can add yet another published property wrapper where we say var error is a dice error and make it optional. Now, here, when we receive a new subscription to roll the dice, we're going to take that error and clear it out. So we don't retain it between dice rolls. Then when we get our catch error, we can, in addition to logging it, we can set it as the property on the class. And now we have the ability to react to this in the view controller. So let's go back over to our view controller, and we will once again subscribe to our view model. And this time we'll subscribe to the error property, and we will sync unowned self error in. And I'm just going to paste in some alert controller code here. So here we're going to create an alert controller and have a dismiss and a reroll button. If they tap the reroll button, we'll call self.rollDice, and we can avoid the self there, but we do need to put a sender in there. And then we'll present this on the view controller. And then finally, we just need to store this subscription in our cancellables. Okay, so at this point now it's giving us an error because this can be optional, and we don't really care about optionals. So here we can compact map and use $0, which is essentially going to eliminate all the nils from the stream going downward. So now sync is never going to see a nil, and the error is non-nil here. Okay, let's run our final example, and we hit roll dice. Let's do it until we get an error. There we go, dice rolled off table. I can dismiss it, in which case it stays at the question mark. And I can keep running it, re-roll it if I want to re-roll the dice. Combine ships with built-in support for creating publishers based on URL requests similar to the Datatask API that you're probably using today. In this module, we'll see how to use this publisher, how to react to different HTTP responses, including errors, and how to decode responses into codable models and more. So a good resource we can use to make arbitrary network requests and get back the data is jasonplaceholder.typecode.com. And so there's a bunch of different things we can fetch there, and it's a good resource for this sort of thing. Another good resource we can take advantage of if we want is HTTP bin. And HTTP bin will allow us to simulate different status code responses. So if we want to test various aspects of our networking, we can do that. So similar to traditional URL session usage, we're going to start with a session and either a URL or a URL request to execute. And so I'm going to put this inside of example 1 here. And what we need to look at is Datatask Publisher. Now, Datatask Publisher, we can get access to by calling session.datataskpublisher for URL and pass in the URL. And that's going to give us our publisher. Now here, the output type of a Datatask Publisher is going to equal a tuple of values that has the data like this and the response like this. So this is similar to a traditional Datatask callback signature, except that we don't have to handle the actual NS error that happens as a result of some sort of network connection failure that indicates the request couldn't be made. And we'll get a value from this if we receive any response from the server, including an HTTP 500 or an HTTP 400 or something like that. Then the failure type of this publisher is going to be URL error. And so that's going to be all kinds of things networking that we might have to handle. So with URL session, it's important to note that non-successful HTTP requests are not considered errors. If an error occurs, this means a request couldn't be made at all. And this could happen for many reasons, including timeouts, SSL certificate errors, failed authentication challenges, lack of network connection, and more. And for the complete list, you can take a look at the URL error documentation. There's a whole host of reasons why these requests might fail. Now, before I continue, I want to make sure that we have this needs indefinite execution set to true, because these are going to be asynchronous and they're going to deliver the results when the network response actually comes back. And so what we're going to do is grab on to this Datatask Publisher. It's going to return a cancelable, so we can call that cancelable. And we need to hang on to this in this case, because this is unlike our previous examples. This one is actually going to go over the network and take some time. And so we don't want it to go out of scope. Otherwise, it'll cancel the request. So then when we get the response back, we can map this and get at $0.data, which reaches into the tuple to grab this. And I'm going to move that above right here. So then we want to call sync, but I want to handle the case where we get a URL error. And for that, I'm going to say replace error with and give it some initial value of, say, empty data. This is just for an example. Then we can map the result of that to string with data $0 encoding UTF-8. That is going to return an optional string. And so now we've converted this publisher that is a URL into an optional string that contains the response. And finally, we can subscribe to it with sync and get back the response and maybe print it out. And if we didn't get that response, then we can print out maybe no body in the response. Okay, let's run example 1 and see what happens. So as you can see, we don't get any output here, and let's add a print onto this so we can actually see what's happening. We see a subscription, we request unlimited, and then an immediate cancel, and that's because cancelable went out of scope. So this is where we might want to set cancelable to nil here, and then we can squelch that warning that we're going to get to assign something to any cancelable. And to do this, we're going to split up the assignment and call this any cancelable optional, and then assign it to this. Okay, so now we can run it and we should see some output. So here we can see, let's make this a little bit bigger. Here we can see we get a subscription. We requested unlimited data or unlimited requests or values from the upstream publisher. And then we finally received a value from the data task publisher. Now, the time between this and this is when that request was actually made. And so there was a little bit of a delay between these two lines. We got back 292 bytes. We got an HTTP status code of 200 with some headers. And then we converted that into a body, which we print out right here. And then finally, it received cancel because we set this to nil in the sync here. And if we hadn't done that, then eventually this would, if I do that, then eventually this will complete. We receive the finished event, but no cancel because we never set it to nil. So that's where that's coming from. So it's important to answer the question, when is the actual network request made? And it's made as soon as something subscribes to this data task publisher. So publishers do their work on demand. So that means if we subscribe to this publisher again, we're going to get another request. So here, if we say, let's turn this into pub like this, and I say, pub dot, map or whatever, and I do this, this is going to trigger a request, but also is this. So that's an important thing to note, that these publishers do work on demand, which in this case is going to start this network request. And it's really important we understand that so we avoid making lots of network requests when we don't mean to. So let's drive that point home a bit. So let's have a function fetch data that returns any publisher of type string and never. So we're going to copy all of this in here. And then we're just going to return, rather than dealing with the cancelable stuff and the sync, we're just going to return that and erase to any publisher. So that's our method. And here I'm going to add a print statement, getting publisher. And we're going to say let publisher equals fetch data. And this definitely needs to be an optional so that we can, because this is returning an optional. And so now we've got this publisher, and I'm going to add a dispatch queue.main.async after and use a deadline of now plus half a second. And then we're going to say publisher.sync and get the response, and we're going to print out either the response or no body. So this is our example, and let's have a cancelable outside that method that we can use. And now I can assign this here to make sure that it doesn't go away while we're running this code. Now we can see that it said getting publisher, and it waited there for a second. Then we got inside this block half a second later and said subscribing, and only then is this network request made. So it had to wait until it was actually subscribed to. And it doesn't matter how many things you chain on to the end. None of these are subscriptions. They're just transforming the publisher, the upstream publisher, and eventually we will subscribe to it, which will sort of bubble up that request. And eventually this gets a demand for some data, and that's what actually does the work. And so what we have to be careful about is when we subscribe to this multiple times, it's going to end up issuing multiple requests. So blindly ignoring HTTP status codes is usually not a good idea. So right here, we're taking the result of the upstream publisher and we're just ignoring the HTTP status code. So we can model these sort of status codes as errors if we want to treat it that way. And that's usually what I like to do. So I'll have something like an HTTP error, and this will adopt the Swift error protocol. And say we have something like non-HTTP response, and this is to handle the sort of most common case that we always want to deal with HTTP responses. Then we'll have a request failed type of error, which will take maybe the status code. And then we can have a networking error, and that will basically just wrap any sort of transport error that happens along the way. So then we can add a description for this to make it a little bit more friendly to work with. And so we can do a description here and switch on self. Here, I'm going to look for a non-HTTP response. We'll do the same thing for request failed, let status. This will return received HTTP and the status code. And in the case of the networking error, we will return networking error and pass in that error. So for these requests that we're about to do, we're going to start using HTTP bin so that we can simulate a 422 response. 422 is typically used for validation failures and other sort of data. It means unprocessable entity. And so this means like if I submit a form and I'm missing some data, that's usually what the server will return. So right here for the URL, we'll grab a new URL, which will be https http bin.org/status/422. So what we're saying is just go fetch this and return a 422. And so that's what this endpoint is going to do for us. And this needs to be string : then we'll return the data task publisher since we have more than one statement. And now what I want to do is on this data task publisher, I essentially want to know if an error happened here. I want to map that error using the map error operator. Now this is going to give us a URL error in, and now I can wrap that in our HTTP error.networking error $0. So instead of just mapping directly to the data, let's use try map. And here we're going to guard let HTTP equals $0.response as HTTP URL response, because by default, it's just going to be URL response. And 99.9% of the time, in fact, maybe even 100% of the time, we're usually working on HTTP. So this is usually something that we'll do. And it's very rare that this is ever going to fail. But if it does, we can return an error here. And because we're using the try map operator, we are free to throw errors in here. So I can throw an error, HTTP error.non-HTTP response. Now, if you contrast this with like traditional completion callback code, usually that's kind of incompatible with exceptions. You can't often take completion callbacks and then throw in the middle of that and then catch it in an outer scope. That's just not something that type of development is geared to take. But in Combine, this is just how things work. We're free to throw inside of our operators if we use the try variant. And so this allows us to halt any work right here. Next, I want to guard that the HTTP.status code is equal to 200. Now, if that's not true, then I can throw the other type of error, HTTP error.request failed, and pass in HTTP.status code. And this will allow downstream callers to catch this type of error and have some more rich data about what's going on. Now at this point, now maybe I don't care about any of the response headers or anything else. I've extracted all the information I need to deal with any kind of error. And now downstream, I just care about the data. So now remember that TryMap doesn't know that we're always throwing HTTP errors. So we've gone from this map error to that, which at this stage, after this step, our error type or our failure type is HTTP error. But then we go through this sort of try map and we can throw whatever we want here. I could go back and I could say throw URL error dot app transport security requires secure connection or something. And there's nothing to stop me from doing that. And so try map will eventually turn our error type back into error, which is not great. So right here, I'm going to use map error again. And I'm just going to use $0 as force cast that to HTTP error. And this is because I'm guaranteeing I know that all the errors that are possible to throw upstream are all HTTP errors. So now I no longer want to call replace error with data. And so that means that we're going to be returning an HTTP error as our failure type to the returned publisher. And the rest of this will just work. So now let's delete this code here. And this code. So we're going to call fetch data. And we need to assign that to a cancelable. We're going to catch any errors that we get. And what we're going to get inside of here is an HTTP error, which is great. Now here, I want to continue to return a string optional downstream. So I'm going to return just string optional. And then here we can just print out that we got an error. Maybe we put a little emoji in there, error.description. And then I can return just nil. And then sync. Now we have sync. We can use sync without the completion part of the callback because the upstream publisher now is a never because we've caught errors. And then finally here we can say if let body equals $0, print body. Okay, so if we've done all this correctly, by subscribing to this, it's going to actually kick off the network request that we defined in fetch data. It's going to catch any errors and show us that description. So let's go ahead and run this. And here we see we get a request. We request unlimited. We get some values. This is the 422 response that's coming back down from HTTP bin. And then we get down to here and we say received 422 and receive finished. Okay, so far we've covered how to trigger a network request, how to just get at the data, and how to handle different responses and how to simplify the possible errors that we can get. Next, let's discuss decoding JSON responses. Most of the APIs we work with tend to return JSON data. Since the introduction of Codable, JSON parsing Swift is really streamlined for this case. If you aren't familiar with Codable, you can read my guide on parsing JSON with Swift to catch up. If we take a look at this response that we're getting from JSON placeholder.typecode.com/posts/1, and we execute that, we will see in our response, we can take a look at what we get, and it gives us back a single post that's got a user ID, title, and body. So we can model that in Swift with a simple struct. So we will model that as a post and make it codable. Then I will give it an ID, which will be an integer, a title, which will be a string, a body, which will be a string, and then the user ID, which will also be an integer. So that is sufficient to decode the same keys in the JSON document. Let's see how we can use a combine operator to automatically decode a response into this post model. The first step is to start with a publisher with an output type of data. So if we take our session and use a data task publisher for that given URL, we're going to want to map this to $0.data to now have a publisher that outputs data. Now we can use a new operator called decode. And decode takes the type that we want to decode into and a top-level decoder. So the type we want to decode into is a post.self. And we need to take care that our response contains this and not some wrapper element like an array or a dictionary that has a key that refers to this post. If we're going to do that, then we would have to add some more models here to sort of wrap that. But our response is simply one post object. Then for the top level decoder, we can use JSON decoder, and we can initialize it like this if we can accept the defaults. And in this case, we can. But if we need to do anything like date format conversion or automatic key naming strategy conversions, then we'll have to use our own instance of a JSON decoder that's pre-configured for that. So now we need to ask ourselves, what is the output type of the publisher that we have now? We now have an output type of post, which is extremely handy. We can now attach a subscriber to this, and here we'll get a sync where we can receive the completion and the value, and in here we get a post.
And this entire thing needs to hang around for a bit, so let's create a cancellables set. And then we'll store this subscription in that set. As you can see, decoding into your own types is really straightforward. It's worth examining how this operator works, so we're going to do that now. First, let's run it, make sure that we get back our post. And we do. I mentioned that we needed to convert the publisher's output type to data first before we can use decode. This is because the decode operator is only defined for types that make sense for it. If we had a publisher of string, well, decode doesn't work with that, so it won't even show up. If I try to use the decode operator and I don't have this map in here, now I'm trying to call decode on a publisher whose output type is a tuple of data and the URL response, and it doesn't even have this method defined, so the compiler can help us out here. So it's also worth noting that this top-level decoder is what is driving that requirement. JSON decoder knows how to decode data, and so that's what type it requires as its upstream publisher. If we were working with a different type of top-level decoder that knew how to accept different types of input data and decode it, then that would be the requirement. So Foundation defines something that looks like this. So it's got an extension on publisher, and there's a decode method, and I'm going to call mine decode2 so I don't collide with the actual one. This is going to take the item that we want to decode and some sort of coder as generic arguments. Then we're going to have the type that we're going to decode into is going to be item.type, and then the decoder is going to be an instance of that coder type. This is going to return publishers.decode, and here we're going to be returning self as the type of publisher that we're using, and this is sort of where you can see those really long generic arguments when we're inspecting the types. Publishers.decode also requires the item that we're going to be decoding into and the actual coder. And before we continue, we have to specify some constraints on this. So the first one is where the item is some sort of decodable type. And I'm going to put these on their own line. And also where coder is some top-level decoder, and where self.output equals coder.input. And so this is where that constraint is defined. So if we have a coder, which is some sort of top-level decoder that knows how to work with dates, let's say, then the input of this would be a date, and that would require that the publisher that we are attaching to, which is self.output equals the coder input. So because we're using a JSON decoder, and JSON decoder's input type is data, that requires self, which is a publisher, requires self's output to also be data. And so this is how we're constraining to only have this method defined when these types line up. And this is really a great use of the Swift type system to enforce these constraints and to also eliminate the surface area. We're not even going to have to deal with the decode method showing up in completion results if it's not appropriate for that type of publisher we're working with. So it's worth noting that this top-level decoder simply exists to provide the input data that this decoder knows how to work with. And for the common ones that we always use, which are JSON decoder and maybe property list decoder, that type is going to be data, but it was always assumed that it was going to be data before. Now there's a formal requirement, and top-level decoder is going to be the one that determines what type of data it uses as input. So while 99% of the time we'll be working with top-level decoders that operate on data, this is not necessarily guaranteed and gives us the compiler safety that we're working with, the expected type, and opens the door for other types of decoders to come in. Another way to constrain operators to only operate on the specified type is to constrain the extension itself. If we have no requirements where we need to relate the output type of the publisher to some other generic argument that exists in this method signature, then we can also say we're only going to add this extension where the output type of this publisher equals data, and then we would be defining an operator that only works in that scenario. So this is a simplified case, but if you do need to make sure that the types sort of agree, then you might want to do it here in the method signature in the where clause of the generic item constraints. So we're going to take a look at how to define custom operators later in this course. But for now, this is how the decode operator is defined on publisher. And I'm just going to comment this out because I don't actually want to implement it, but I would like to leave it there as sort of a template. Okay, let's talk about retrying failed requests. Networking is finicky. It is just a truth that we have to deal with when writing apps that talk to the internet. The user might be walking out of their house and switching from Wi-Fi to cellular. They might be driving through a tunnel or taking the subway, or the server could be experiencing a temporary hiccup. In many of these cases, retrying requests is a good way to smooth over these issues, which are minor but expected, and the user would never have an adverse experience. Why show an error message to the user if retrying the request would just make it succeed? So we can hide this temporary issue completely from the user, and our apps will feel more resilient as a result. Now, I want to make a quick note on idempotency. Idempotency means that you can retry the same operation over and over again, and it will only be done once on the server. Another way to put it is that there are no side effects that sending the same request multiple times will cause on the server. So make sure you're only considering retrying requests that are truly idempotent. That is, they can be run multiple times without causing any kind of adverse side effects. And usually this means GET requests are okay, but you're going to have to examine this for your use case. So combine ships with a retry operator, and it is deceptively simplistic. You provide the number of times to retry, and it will catch upstream errors and resubscribe to the upstream publisher for you. Once the count has been exhausted, errors are passed downstream just as normal. So let's create an example that will fail for us in a controlled way. Here we're going to be fetching these posts from this test endpoint, and I have this temporary issue error that we're going to be dealing with, and a simulated errors integer that we're going to use to simulate a few fake errors. So let's implement this fetch post method and make it sometimes fail. So we're going to use session.dataTaskPublisher for URL and pass in that URL. Then we're going to use TryMap. TryMap is going to let us inspect the state. In this case, I'm going to be expecting our simulated errors and see if we have any. And if so, I'm going to take simulated errors and subtract 1 from it, and then throw temporary issue. And if we have no more simulated errors to throw, we're going to return $0.data. Next, I want to decode this into post.self using JSON decoder and erase this to any publisher. So now we've built our fetch post method. So what I'd like to do now is say publisher, which is currently a publisher of post objects. I want to call that, and we know it can fail, so I'm going to call retry 3 times. Then we're going to sync to receive the completion and the value. In each case, we'll just print those out. And then we can store this subscription in our cancellables set. So what I'd like to do is see exactly what's happening here. And so we're going to add a print statement onto the end of this publisher so we can see what's happening. And now we're going to run it. Okay, so we see that we received a subscription, it requested unlimited, and we received this error temporary issue. Then we received another subscription and requested unlimited again. And we received an error temporary issue. So you can see that retry is actually resubscribing to this publisher, and resubscribing to the publisher is going to trigger another request. Finally, we get through. It is retried for the 3rd time, but we have no more errors to throw. And so this time we actually get a successful value, and the downstream subscriber, the sync, is unaware that any of this happened. So this is really great for things that are temporary issues. Now, what we can see is if I say I only want to retry 2 times, and I run this example again, well, I am throwing 3 errors, and so because I haven't ever seen a successful response after 2 retries, well, now it's going to give up and pass that error downstream, and we get our completion handler here, which tells us that we received a failure. So with this, we already have a design that can silently smooth over temporary glitches. However, we don't always want to retry. Usually this depends on the type of error we receive. So I'd like to only retry certain HTTP responses and errors. So we can extend our HTTP error enum from earlier to provide this decision. So I'm going to take the HTTP error enum that we had from last time, and I've added a couple of others. We've got server error for 500, HTTP 500 level things.
We've got request failed for things like HTTP 400 level requests, things where there's bad input or whatever, or authentication is missing. And then there's networking errors, and then there's decoding errors, which means the response couldn't be interpreted because we have either the server added some things or changed some things, or our client isn't properly decoding some structure. So it really depends on the type of error whether or not we can retry. If we got back some sort of non-HTTP response, should we retry this request? If the server told us we had bad input, should we retry this request? Probably not. If we received a server error, should we retry this request? Definitely. And if we receive some sort of network error that we are not connected or something, should we retry it? Absolutely. But if we get a decoding error, meaning we couldn't interpret the response, retrying is just going to give us the same error again, so we shouldn't retry in that scenario. So what I'd like to be able to do is sort of abstract that knowledge and say, is this a retryable HTTP error or not? And make that a Boolean. Here we'll switch on self. And here I can say, okay, well, if it's a decoding error, we're just going to return false. Can't retry those because we're just going to get the same response and it'll fail again. Next, I'm going to look at request failed, and then we're going to unwrap the status so we can look at it. So there are some statuses that I definitely want to retry, but in general, request failed usually means like you shouldn't retry it. But one of those is a timeout status. This is a HTTP 408. And another one is a rate limit status. And this one is 429. So this usually indicates that you've made too many requests and you need to kind of cool down a bit. Now, I am about to retry these requests, so this can exacerbate the problem, but we'll talk later about how we can retry with a delay. So now I just want to return whether or not the status that we got is included in the set of these two statuses. So let me create an array and say, if it contains the status that we got, then we're going to retry, otherwise we're not. And then finally, for these others, we've got server error, we've got network error, and we've got non-HTTP response, which I'm going to determine as some sort of temporal issue. In all of these cases, I'm going to say, yes, go ahead and retry those. Okay, so now we have sort of modeled the decisions of whether or not to retry. And real quick, I want to mention, if you would like to brush up on HTTP status codes, you can check out httpstatus.es. And that is a handy reference for identifying what all of these are supposed to mean. Okay, so going back to our fetch post method here. So I actually want to move this HTTP error up above this fetch post method. So what I'd like to do is translate these HTTP responses into these HTTP errors that we're seeing. And as we saw last time, we had to use TryMap to convert the data into an HTTP URL response. And that's usually what we want to work with. So let's say I take the publisher that we have, which is giving us data and URL response like this. And what I'd like to do is make sure that we have an HTTP response out of this. And if not, we can throw HTTP error.non-HTTP response. And then downstream, we can sort of simplify this by just saying, just return an HTTP URL response downstream. So this is kind of a handy little snippet that we can use to make sure that we're sending back or sending down the appropriate, expected HTTP status or HTTP URL response so that we can get things like response headers and status and stuff like that. All right, so the compiler needs a little bit of assistance to say that we are returning a data and HTTP URL response tuple as our return value. So this is so useful that I think that I'd like to make this into a custom operator. So let's add an extension on publisher. And we talked about this last time where we can add extension on publisher and constrain it to specific types. So I might say where the output type equals data and URL response. And we can give it the prefixes that it's going to be expecting like this. Now let's create a function called assume HTTP. This is going to return in any publisher with an output format of data is data and HTTP is, or rather response. We could probably use response. So it acts just like the other one, except it's an HTTP URL response. And of course we need to define the error, and this time we're going to be using HTTP errors. So inside of the body of this function, we can just compose this based on other operators. So I can just take this and cut it and put it right here. I'm going to call try map on self and do exactly what we were doing before. Okay, if I try to use erase to any publisher here, what we're going to see is that it can't convert an any publisher of an error to an HTTP error. And that's because TryMap is going to assume that the failure type is error because it doesn't know what types of errors we throw inside the block. So we're also going to have to call map error to deal with this. Now, what's nice about this is we can say if the error is already an HTTP error, then I'm going to just return it as force casting to HTTP error. So that way we sort of let any errors thrown from here be passed downstream. So if the error is not an HTTP error, then we can return an HTTP error that does handle this type of error and say that we are getting a network error. So I want to just make sure that we do this so we don't just double wrap any non-HTTP responses and call that a network error, because then we'd have sort of nested HTTP errors and that doesn't look great. So now we have this HTTP friendly publisher that we can work with. This makes everything easier to read when we use it. So now I can just say assume HTTP, and now the downstream map is going to receive data and an HTTP URL response. And we can use that to inspect the headers. So it's worth noting that the output type of this is data and HTTP URL response, and the failure type is HTTP error. Okay, so that's much cleaner. So now what we want to do is implement conditional retry. So we have a property we can inspect to see what type of HTTP status we get. We now need to somehow conditionally apply the retry operator, but only in certain cases. So how can we do that? Well, this is a really good use case for catch. Though since we want to be able to throw non-retriable errors immediately, we're going to use try catch. Okay, we have one more step that we need to deal with, and right now we're returning error, and I want to return HTTP error from this. So TryMap translated the error into actual error, and so did decode. And so what I'd like to do here is map error again at the end of this. And we're going to have to do something similar to this. If it's an HTTP error, then we're going to let it pass through as an HTTP error. Otherwise, we're going to call it a networking error. And so let's grab this in. So we'll talk about how to clean this up in a bit, but I just want to make sure that the output error type that we get, the failure type, is HTTP error so that we can use it down here. So with that in mind, I'm going to take this retry and replace it with a try catch. Here, I'm going to be given the error, and I need to return the same type of publisher that the upstream is producing, which is any publisher of post and HTTP error. So now that I have an HTTP error, I can check to see if it's retryable. And here I'll just print retrying so we can see what's going on. So now that I have a copy of this publisher, I can use it inside the block and I can return it saying publisher, and then chain on my own operators onto the end of that. So I can say, I want to retry this 2 times. Now I'm doing it 2 times because the first request has already been made. We're catching any error that happens, seeing if it's retryable, then we're going to retry up to 2 more times inside of here. Then erase to any publisher. Otherwise, we're going to throw whatever error happened. So this allows non-retriable errors to continue downstream. So what you can see here is we're using a publisher inside the try catch block. This is where we add the retry logic so we can conditionally apply it. With this approach, we can decrement the retry count by 1 because we saw that 1 request was already made upstream. So then we have our sync output so we can see it, and we also have our print statement so we can see it. Let's run this. And what we see is we receive a subscription, request unlimited. We got our temporary issue, which was converted into this network error, and we are now retrying, and now we get our post. So one thing I want to point out, and we're going to add another print statement up here where we are throwing our temporary issue. I'm going to print simulating error. Okay, so this way we'll be able to see it in the logs when we're actually simulating the error, because what we see is we only have a retry once, but then it says simulating error, and then we get our post. So it is important to note that we're dealing with two different publisher streams here. We've got one that's being printed from here, but then we're subscribing to this again, and this one is not being printed, so we don't actually see the individual retries happening here. If we wanted to see that, we would also want to add the print onto this one so we could see what's going on. So while this does allow us to conditionally apply this, what happens is we no longer check through this try catch block because publisher.retry is doing the logic inside of here. And so we're no longer checking to see if our errors are retryable. And so this is kind of a minor nuance, but it does seem like an okay trade-off for most apps. If we got an HTTP 500 and then we retried it and then we got an HTTP 503, it's not going to interpret that separately. It's just going to keep retrying as long as it's getting an error. So now that we have a conditional retry, it makes sense to add a little delay before retrying requests, especially for that rate-limited response. So as we've seen, one limitation of retry is it immediately resubscribes, and that's often not the best approach when dealing with networking errors. So what I'd like to do now is add a 1-second delay between attempts. So let's turn our attention over here to the fetch post method. And right here, where we're simulating this, instead of doing this, I want to return a HTTP error dot request failed with 429, indicating that we're being rate limited. And it's going to be probably a good idea to take this and make it into its own custom operator so that we can separate the simulated error code out from the HTTP type of code that we would use in a real app. So I'm going to cut all of this, and we're going to make another extension on publisher. This time we're going to constrain the output type to be data, and the response will be an HTTP URL response, and that the failure type of this is HTTP error. So basically this is going to make sure that the result we get from this comes after assume HTTP. Next, we're going to have a function called simulate fake rate limit. And then we can pass in a when escaping closure that returns a Boolean, and this is going to tell us when to apply the fake rate limit. That whole thing needs to return in any publisher of the same type that we're dealing with. Then a failure type of HTTP error, and your colon there. Inside of here, I want to check on the response. So to do that, we can use the map operator, and that's going to give us the data and the response that we're getting. But I want to check first that block to see if we need to do this. And then inside of here, I want to call print and say simulating rate limit HTTP response. But if I try to do this, this print is now ambiguous because we're inside of a publisher, and publishers have the print method defined. So I need to use swift.print to make sure that it is using the correct one. Okay, so now I want to indicate a brand new response type. So I can create a new response, which will be an HTTP URL response. And inside of here, we can specify the URL and the status code, etc. So the URL is going to be whatever URL we were dealing with from the response. The status code here is going to be 429. The HTTP version, we can use nil, and header fields, we can use nil, and then we'll force unwrap that. So here I can return data, which is the same data we got, but this time I can return our new fake response downstream. Now, if this block returns false, then we have no more errors to do, and I can swift.print, no more errors, and then we'll just return the data just as is. And then the end of this map, we're going to call erase to any publisher. Now let's let the compiler catch up, and it did figure out the response of this, so this is good. So now we have an extension on publisher scoped only to the output and failure types we can work with. We're going to first check the result of this block, which will be applied externally, so that we can know whether or not it's a good idea to return this error or not. Okay, so let's go back to here. And now I can, after our assume HTTP, I can say simulate fake rate limit when, and we're going to pass in a block that takes the simulated errors, subtracts from 1, and then returns simulated errors greater than 0. Okay, so now we're getting an error saying that decode needs to work on a publisher of data, and right now I'm still returning the data and HTTP URL response. So what we need to do here is use try-map to map, right? What we want to do is get at data, but we only want to do that in certain cases, and we want to make sure we throw the appropriate HTTP errors in those various cases. So now I can say switch on $0.response.status code. And it's probably a good idea, again, to use data as data, response as an HTTP URL response, just to help the compiler out a bit and say that we're going to be returning data. Okay, so if we got a 200, then we'll return the data. If we got a 400 up to a 499, now we can return HTTP error.request failed and pass in that response.status code. And if we got something in the range of 500, that is a server error. So we can return HTTP error.server error. And again, pass in response.status code so that can be interpreted later. Now, I'm going to add a default case here because the compiler is going to force me to, and I want to put out a fatal error here because I want to say that we are not handling some sort of HTTP response status code. Now, I'm not handling all the various status codes here. And the reason why I'm doing this fatal error is so I can just catch it quickly and we can fix it. But for the sake of this example, I just want to keep this a little bit smaller. So if we ever see one of those, it'll blow up loudly, we can fix it. These need to be throwing those errors. Okay, so now our HTTP error handling code is completely separate from that fake error response code that we had earlier. So now let's add a catch to intercept these errors and add a little delay. So recall that catch and try catch both expect a new publisher to be returned. In our case, we can use either, but to keep things simple, I will just add a delay to any error that we get. So right here, we're going to add a catch, and we're going to get in an error, and this is an HTTP error. And here we need to return the same type of publisher that we're working with. In this case, it's going to be a post, and I'm actually going to put this down at the very end here. So catch errors. We want this to be a post HTTP error. So if we get an error, I'm just going to return a new publisher, failing with this error. But before I publish it, I want to delay for some period of time. And we'll say delay for 1 second on dispatch queue.main. Then erase to any publisher. And that return we don't need. So this is going to allow us to grab the error, and we're still going to fail with that error, but we're going to delay before doing it. And this will allow us to not hammer a server. If we get an error, we're going to wait for a second, and then we're going to try again. And again, because we're past an HTTP error, I could add the retry delay as a computed property on our enumeration here and be able to check to see, okay, for rate limits, I want to wait for 4 seconds, but for everything else, I want to wait for 1 second or whatever. So now we have a nice HTTP-friendly publisher stream that retries failures and adds a delay between retries. Let's just see this in action. Here I'm going to add a print delaying for error, and we'll add that return back in. Let's run it and make sure that this is working. Okay, and as you saw, it adds a little 1 second delay every time it gets an error. So this example works well because our delay is always caused by a thrown error, which we then catch with the catch operator. And the catch operator expects a publisher to be returned, so delay just fits in naturally there. I can just add it onto the chain here because I'm already returning a publisher. So what if we wanted to add a delay in like a map statement? If you recall, map is going to take, if I say publisher.map, map is expected to take in this post and then return something else, like maybe the post title. But I'm returning a value here. So let's say we wanted to add a delay in this code here and delay for whatever reason. At this point, I'm returning a value here. I'm not returning a publisher. So if I wanted to add a delay here, what I would have to do is say, let's just add a superficial delay here. So this is right now accepting data. And I can now return $0 wrapped in a just. I can set the failure type to HTTP error.self. I can add my delay here for 1 second and dispatch queue.main and then erase to any publisher. So what have I done here? I've taken in some input data and now I've turned that data into a publisher of data. So doesn't this turn us into a publisher of publishers? And the answer is yes, it does. This is actually pretty common in Combine, and there are several operators to help you work with these. So one of the ways we can work with this is by saying, I want to switch to latest. Switch to latest will basically take a publisher of publishers and then always subscribe to the latest one emitted from the upstream publisher. So I'm going to pull this out and let's use a more contrived example down here. So let's say we have some numbers here and they are arrays of arrays. So we have 1, we have 2, and we have 3, like this. Now, if I flatten this array, this is going to give me 1, 2, 3 without the nested containers. And if you think about arrays like containers rather than a data structure, think of it like a container. When you flatten, you end up with one level of containers removed. So here, if I take X and I make a publisher out of it, now I'm making a publisher of arrays. If I map those to each one's publisher, now I have a publisher of integers. I can use switch to latest to turn that publisher of integers and then just subscribe to it and get the integers out. So at this point, I can sync and receive a value, and now I just have an int, and I can print it. So if we see this example here, we get 1, 2, and 3 emitted as individual events because we transform the publisher of publishers into a single stream of integers. So far, we've gathered some useful functionality for some reusable components we can use across any HTTP request. And so I'd like to take some of these and sort of move them into their own file that we can reuse between our examples and use in future example projects. So the first thing I want to do is take this HTTP error enum, and we're going to cut this, and I'm going to move it over to this other file I have in the playground under the sources folder called combine plus HTTP. Now we're going to paste that in here, and one thing about this is it has to be public so that, and this is how Playgrounds works, so that it can be used inside of the playground. It's going to treat the external files as their own separate module, and so those will have to be public. So basically anything reusable and not specific to our one example, I'm going to move over there. So that includes this assume HTTP. I'm going to cut that as well, and we're going to move that over here. So now we have an extension on publishers to assume HTTP responses. Then we have this simulate fake rate limit, and this is specific to our example. So I'm going to leave that here because that's not something we want to carry around. And then we take a look at our fetch post method. And this is basically what we're going to be doing when we're dealing with networking. We're going to call session data task publisher, assume HTTP. There's some custom logic here. And then this is pretty common. And this try map is going to be intercepting the data and the response, looking at the status code in order to decide whether it's going to throw an appropriate HTTP error or not. So I'm going to cut that. And if we remember that the response is data here, so what we're doing is we're taking this HTTP response from here along with the data, and we're turning it into the data, but also throwing an appropriate error. So we're sort of just morphing this into how we want to work with it. So that's going to be an extension, a public extension on publisher, where the output type is data and the response here is HTTP URL response. Then we'll have a failure constraint to make sure that the failure is HTTP error. Then we're going to have our function and our operator here. I'm just going to call this response data. And this may seem a little bit generic,
but I think that this makes sense. And this is going to return an any publisher of data and HTTP error. So now inside of here, I can call try_map. It will inspect the status code from the upstream response. If it's 200, it'll let data flow downward. Otherwise, it will throw some HTTP related errors. And if we didn't handle any of the cases, we're still going to get this sort of fail fast fatal error. And this is one reason why I would suggest that this is not ready for production code, but it's certainly ready to iterate on and decide exactly how we want to handle request or response status codes that don't fall in the set. Like for instance, 200 could really include 200 to 299 if you want, because all of those indicate some successful response. But for now, I'm just going to leave it like this, and we'll just fix these if we run into this error. Okay, let's spell publisher correctly. And at this point now, it's saying I can't convert this, and that's because we need to erase to any publisher. Okay, and again, as we saw last time, try_map is going to set the error type of the downstream publisher to error, and we're going to have to call map error on this. And in this case, what we need to consider here is the fact that upstream, all errors are HTTP errors. So this is only being applied to a stream that has HTTP errors. Now, if we get into this block, we are only throwing HTTP errors. So I can guarantee that everything from this point onward is an HTTP error. And so I'm safe to just cast it like this. I don't need to do any checking. I don't need to wrap any other types of errors. I know that I'm safe to do that. Okay, so now we have an extension on publisher called response data. And the next thing I want to do is sort of encapsulate this behavior here, where we're decoding this type, and then we want to check to see if we get a decoding error. I want that to be sort of wrapped up in our HTTP error as well. So again, I'm going to create a public extension on publisher. We're going to constrain this on an output type of data, and failure equals HTTP error. So the method that I'm going to use here, I'm going to call it decoding, and this is going to resemble what we already kind of took a look at and sort of model it after the existing decode method, except it's going to also wrap the error handling and wrap it in the HTTP error for us. So here we need to decode some item type and use some coder. So the type will be item.self, and the decoder will be whatever coder type we use. This needs to return an any publisher of that item type and HTTP error. And then before we implement this, we need to add our constraints on the generic items here. So the first one is item is some decodable model. Then coder is some top level decoder. And then finally, self.output equals that coder's input. So let's sort of organize this a little bit better. Okay, so now I can paste this in, and I can say, okay, decode to item.self and use whatever decoder was passed in here. So I can use decoder there. In fact, I don't use item.self because it's passed in as item.self there. So I can just use the type. That needs to be item.type. There we go. Okay, and then we're checking to see if the error coming out of this is a decoding error, then we can wrap it in a decoding error. Otherwise, we know that because we constrained this to types that are HTTP error, that there's nothing else we need to do here. We just let the error flow as an HTTP error. And then finally, we can erase to any publisher. So let's fix the indentation on that. And now we have a handy decoding publisher that knows about our HTTP errors. Okay, so with all of that, we can now delete this code, and we can say response data in order to turn this into data, and then say decoding, which is our version. This is going to be decoding post.self using the JSON decoder. And this is much more readable and allows us to quickly iterate on our networking code
and do examples and stuff like that, but not have to constantly map to data and ignore HTTP responses that are actually failures and things like that. Things are all going to flow through the same thing and leverage our HTTP errors that we already wrote. Okay, so this combine plus HTTP, we're going to save this file and use it in future examples. All right, let's talk about sharing results. So let's create a quick publisher. I'm going to say let publisher equals session.dataTaskPublisher with URL. And then we're going to use our helpers that we made. So assume HTTP, get the response data, decode that into a post. So we're going to use decoding, which is ours, post.self, using JSON decoder. And then I want to replace errors with maybe just an empty post so that I can more easily work with this stream. So we'll just do, an empty one. Okay, so now I've got this publisher and I want to know when it's doing its work. So we're going to add a print and say, data task here. Okay, so then I can assign to that. So I'll say publisher.sync and we'll get the post and I'll print here. I'll say number 1 got this post. And we'll also print assigning number 1 like this. And so then we just store that in any cancelable or in our cancelable set. And now we can run this and now we can see it gets some data and number 1 receives its value. And let me just add in some dividers just to make this a little bit easier to read. Okay, so here I want to do the same thing again. I want to take this exact code and I want to do it again, but I want to do it again later. So we're going to say dispatch queue.main.async, and I just want to do it like kind of immediately later. So let's say assigning number 2 and number 2 post. Okay, so if we run this, now I want to show you what we receive. Okay, so it says assigning number 1, data task received a subscription, and data task request unlimited from the number 1 sync subscriber. Now it says assigning number 2, and again, data task receives a subscription and requests unlimited value. So we've got 2 different data task publishers going on. One of them is doing this work for number 1, one is doing this work for number 2. And so we receive a value and we go down here and look, number 2 got its result first, and then data task again received another value. So we've done 2 requests and deliver the results to their subscribers. So this is problematic. And what I'd like to be able to do is kind of share this between these 2. So the crux of the issue is that this is working with a publisher, which is URL session.dataTaskPublisher. Now, if we hold Control and Command and click on this, we'll go to the definition of that in the Foundation framework, and you can see it's implemented with a struct. And many, or probably most, of the publishers that we work with in Combine are actually structs, and that means they're value types. That means if I say that I have a publisher, and then I have another one, and I say pub2 equals publisher, well, now I have a copy of this one. I don't have a reference semantic to the original publisher. And so that means I subscribe to this again. It's like, like the first one never existed. You just get totally separate subscriptions, totally separate chains of delivery, and that becomes a problem. Now you can make a publisher implement reference semantics if you use a class. And if we use the share operator, that's essentially what it's going to do. It's going to take the upstream publisher, which is this whole chain here, and wrap that in a class and use that as the publisher will subscribe to. So when publisher is subscribed to for number 1, we're going to get the exact same stream that number 2 will get. So if we run this now, notice that it says assigning number 1. This is the first request, the first subscriber, and it requests some values. Then it assigns number 2, and notice that we're not receiving another subscription. There's only 1 subscription going on here and only 1 demand. Assigning number 2, data task receives its value, gives us back this response, and then it delivers the results to all of the subscribers. So we get number 1 and number 2 here, and then finally we get it finished. So share is pretty nice for doing things like this, where if I have, if I've exposed a publisher for some data and maybe that data comes from the network, or maybe, it's expensive to create or compute, and I want to share the results with anyone else who wants that data, well, share is really handy for that. But there is a little bit of a problem in that share isn't going to do this forever. So if I change this to async after and I give it a deadline of say now plus 2 seconds, now let's see what happens. We can see assigning number 1, we get our subscription and we get our value. It delivers it to its current subscriber and then finishes. And then number 2 comes along and says, okay, I'm ready. Well, at this point, we're reusing the same subscription and that subscription has finished. So it's not going to give us this value. And so this is kind of the problem with share that we have. If we have like kind of different setups, or, maybe we're not going to connect to that publisher stream for, a period of time. Maybe it's waiting for view did load or view will appear or something like that. And so sometimes you want to set things up ahead of time and just kind of wait until everything's set up and then you can tell it to continue. So we can do that with this publisher chain. On the end of this, I'm going to say make connectable. Now we've already seen connectable publishers when we looked at timers. Timers are connectable publishers, and timers will start their work, they'll start their timer immediately on subscription. And sometimes that's not what you want. And so timer itself is a connectable publisher. And on connectable publishers, you can say auto connect if you want the behavior, like normal default behavior of doing its work when it's first subscribed to. But for connectable publishers, you can also connect later. So here I've made publisher a connectable publisher. And what that means is publisher now has a connect method. So what I can do is I can do all of my setup, even if that setup takes time. So I'm going to wait until after I've assigned number 2 and then say publisher.connect. Now, if I run this, I'm going to notice a little bit of a problem. We'll see assigning number 1, it waits 2 seconds. Assigning number 2, it started its work because I connected, but then it canceled. Now, the reason is, and this may not be obvious because I didn't actually get a warning, is that this connect method returns a cancelable. So I actually need to take that cancelable and store it in our cancelable set so that it can hang around. Now, if I've done that, now I've hung on to that connectable cancelable, and now I get assigning number 1, then wait, then assigning number 2, then finally I connect, which issues all the work, and now both of them are guaranteed to get the results and the completion.